So we're finding the average rate of change, but just with the function rule instead of the graph. But what does that mean to do? Nope. We don't care at all about the form. Chris, do you ever read your notes? Yep. Make sure you do. Get them in here. Right, f of b minus f of a means what? Yeah, so in this case, a and b. So we're going to plug in for the second coordinate first. So 2 times 1/2 squared minus 2 times 1/2 plus 1 minus, use brackets because this whole thing needs to be subtracted. And then we'll have 2 times -1 squared minus 2 times -1 plus 1. And then on the bottom that. That's negative. I did not see that. Let me go fix that. Negative, negative, and negative. There we go. That's your setup. You should write it out. Okay? If you do one of these on an assessment and you just give me an answer because you just did it all in a calculator, I'm not going to give you credit for it. So make sure you're showing your thinking, showing where stuff comes from. What's a half? Oh, what's -1/2 squared? Yeah, positive 1/4 times 2 is a half. And then -2 times -1/2. That's 1. Okay, over here, what's -1 squared? 1, so that's times 2 is 2. And then plus 2 plus 1. -1/2 plus 1 or minus -1 is a positive half. Okay, continuing on. Positive 1/2 plus 2 is what? It's 2 1/2. But what is that as a improper fraction? Okay, and then minus 2 plus 2 plus 1, so minus 5 over 1/2. Okay, what's 5 halves minus 5? Well, how many halves is 5? So 5 is 10 halves. Okay, so 5 halves minus 10 halves is -5 halves over 1/2. Okay, what happens with those 2's? They cancel to leave what? -5. How'd that go for you?
Not good at all. I even checked my notes. I can do it.
So, questions on it? Okay. What does the -5 mean?
It's the average rate of change.
Okay. Between,
From the vertex.
not the vertex. Between what?
Point A and point B.
And these are x coordinates, right? That is not a point. Those are just x coordinates of 2 points. What kind of function is that? It's quadratic. What does it look like? Actually, in fact, why don't you graph it? Yeah, let's look at it. All right, so quick sketch. Actually, let's do a little bit better than a sketch, but it's not going to be perfect on here. Where's the vertex?
0.5 is what I got.
Okay, so it's -b or opposite of b over 2a. So opposite of -2 over 2 times 2, which is 1/2. Right? It's 2/4, which is that. If we plug that in, I guess we're going to have to do this again.
You're gonna end up getting.
No, we did -1/2. But that's okay. If we just plug in 1/2, this first one is the same. So it's still going to be a half, but this will be now -1 plus 1, so those cancel, so that's going to be positive a half. Okay, so that's the x coordinate. Y coordinate is positive a half. So it's kind of like tucked right there for the vertex. Does this open up or down? Opens up. We know that. How come?
Because A is positive.
A is positive. What's the y-intercept? 1, so it's right there. Axis of symmetry is at x equals a half, so I can just reflect that straight across. So we're starting to see a little bit of our parabola there. And what else can we do to get some more points? Like, huh? The graphing pattern from the vertex. So over 1, up what? Yeah, and remember when you're starting at a half, 1 over is to the next half. Same thing with vertically. So from half, we go 1.5, 2.5. Left 1 is to negative a half, up a half, and another, or up 1, up 2. Okay? How about over 2 what? Okay, so this is going to be a little bit of an eyeball, but I can't see that. Okay. So our two coordinates were -1 and -1/2. So I want you to notice, look at our slope was so negative, it was -5. So that's like going through here. Does that make sense why it's so steep now?
Yeah.
And negative? Think about just a small change in the x coordinates would have made this very positive, right? So right around that vertex, your average rate of change can be a lot different depending on which coordinates you pick. Okay, are we okay on average rate of change?
Now I am.
Oh, on that?
Yeah.
Okay.
They gave us a point. Is the point like you have a -1 and -1/2?
That's not a point.
Where's my scroll bar? There it goes.
Yeah, this is not a point. It's x coordinates for two different points.
Okay.
Okay. And partially you can tell because it's brackets, not a parentheses. But it could say it in, yeah, I guess it could say it in a textual context, like between x equals this and x equals that too. Okay. Any other questions? Give me a fist of 5 on that whole thing, including the graphing, please. Okay. Your quiz, I'm planning it for Friday. Your quiz will be 2 sections, a no calculator section and then a graphing calculator section. And that first graphing or no calculator section is all this. It's average rate of change, it's graphing, it's key features. So you got to know this, and it will be all 3 forms. So standard, vertex, and what we'll talk about today, which is intercept form. I will give you a little bit of time to review tomorrow, but we're not going to spend the whole period. And then your quiz will only be like half the period, and then we're going to move on to the complex number system. Because the test will come very quickly after that. I imagine we could get to the test by probably Thursday next week. Maybe. Yeah, probably Thursday next week. So, it's because this stuff is new, and then most of the stuff after this quiz is not. Well, that's not true. Have you guys done completing the square before?
I think you showed us once.
Okay. We had to do it when we found the equation of a circle.
Yeah.
So we'll talk through that, and then the imaginary stuff I think you said is going to be new, right? Okay. So probably Thursday. Try this one. Probably have to zoom that, it's pretty small. So I've added, so the main question is what is the maximum height, but I also want you to answer those questions as well. But let me zoom it. So remember that the maximum is where?
The vertex.
Yeah. But it's the y value of the vertex. So, but we need the x value first. And that would be negative 32 over 2 times negative 16, which is 1. Which question on here does that answer? And what are the units for the 1?
The first one.
So it went 1 foot? Even though it started 80 feet in the air? Okay. So 1, what? Second, right? So it answers when does it reach its maximum height? At 1 second. Okay, and then maximum height. So this time it only traveled upwards for 1 second before it started coming down. And if you do that, you get 96. 96 what? Feet. Okay. So that's the maximum height, 96 feet. All right, it says interpret each number in the function rule. So what is the negative 16? What is it? It's feet per second squared, and that's acceleration due to gravity. It's half of it, actually. The half is part of the physics that it takes to get the equation. Okay, what's the 32? That's the initial throw speed, what we call velocity. And this one is 22 miles per hour, which is way more reasonable. Okay? Everybody in here could probably throw that fast. So that's the initial velocity. Which direction does it go? Which direction did the initial velocity put this pebble? Up, right? Positive is up. Okay, what's the 80?
The initial height doubles us.
Nope. It's the cliff.
Yeah.
You're standing on an 80-foot cliff. I suppose if you're technically analyzing this, it would be the height from which you threw it on top of the cliff. So probably like 80 feet from your hand, maybe 75 feet from the ground. The cliff would be. How do we figure out when it hits the ground?
So that y equals 0 is also
Yeah.
the x.
So y is the height. So ground means y equals 0. All right, what can we do first?
Try to
Yeah, GCF out negative 16. Okay, and then that just divides off, so it's basically gone. So we need to solve this for the zeros. How? Does it star? Are there factors of negative 5 that add up to negative 2? No. So what else can we do? Okay, so we get negative or opposite of negative 2 over 2 times 1. Remember, we're just doing it on the inside. So A now is just 1. In fact, before I start writing that, maybe I should rewrite this. Okay, so opposite of -2 over 2 times 1, plus or minus square root of -2 squared minus 4 times 1 times -5. And then the denominator is the same for both of these. Okay, at that point, you could just plug that in your calculator if you're using a calculator, but let's do it without one. So we get 2 over 2, which is just 1. Why is there a 1 there? I told you about this yesterday. Relate it back to something we've already found in the problem.
The time, seconds at which it reached its maximum.
Okay, so that's the x-coordinate of what?
Time.
Of the vertex. So think about this thing as coming down like this parabola. Yes, our starting height is here, but the parabola, in terms of math, the parabola just looks like this. Okay? It comes down and hits this x-axis in 2 places. That's what we're finding now. And they are perfectly symmetrical about that axis of symmetry, in this case where x equals 1. So we say 1, remember this from yesterday, 1 plus some total that we're going to find with the square root part. 1 plus gives us the right x-intercept, and then 1 minus gives us the left x-intercept. Remember that? Okay, that's why it's a 1. That's why it looks familiar from earlier in the problem. Because we're starting from that vertex x-coordinate. I should, by the way, this is all x's, right? When we start doing the quadratic formula, it's x equals 1 plus and 1 minus. Okay, so we get 4, and then this is 20, so square root of 24. And if we simplify square root of 24, what can we do with that?
Square root.
Yeah, good. Which are what?
There we go.
4 and 6.
So 2 root 6. The nice thing and the reason to do that is because that 2 will cancel that 2. I'll write it out and then we'll do it. This thing is slow today. See that? Okay. 2 root 6 over 2, those cancel, and now we're left with just 1 plus root 6 and 1 minus root 6. In other words, this distance is root 6 from the vertex. So minus and plus. And of course we're starting here at 1. Okay? So what is root 6 roughly? I mean, you're taking a guess, so 2.5 is probably not too bad. So if we do 1 plus 2.5, when will it hit the ground? Did you say 8.5? Oh, okay. Roughly 3.5 seconds. Guys, note we have done this analysis of a legit. Everything in this problem is legit, right? I have stood on an 80-foot cliff and thrown a rock off. I can absolutely throw it 22 miles an hour underhand. Everybody in here probably could. So everything in here is legit. We have analyzed this with no calculator, right? Takes roughly 3.5 seconds to get to the ground. And it went at maximum height of 96 feet off the ground. Not off your cliff, but off the ground. How'd that go?
I don't want
We have the right idea, just didn't factor so the numbers would be.
Yeah, that would be hard. It still works, it's just a lot bigger.
Yeah.
So always, always, always check for a GCF before you do anything with the quadratic. Any other questions or any questions at all? Okay. Guys, when you get down into the physics of this, if I don't throw if we just stand at the top and just drop it, we don't throw it up first and just drop it off, you can actually use that relationship to figure out how high the cliff is, which is cool. How? Any thoughts? I'll give you this thing is negative 16t squared. If we don't throw it up, then the initial velocity is 0 and that term disappears. Okay? So how could we use that little relationship? Think about standing on a cliff or standing on a building or whatever. How could you use that relationship to figure out how high up you are? I have actually done this out in the woods before.
I mean, like the speed at which it comes down, and then how long it takes for it to actually hit the ground.
Which one of those can you measure while you're standing there?
Times.
Yeah, and there's going to be a little bit of an error depending how far down it is, because sound is fast, but it's not that fast, right? Like, it'll hit, then you'll hear it come up, if you're listening. If you can see it hit, that's instant, because speed of light is super fast. But if you're listening, like maybe you don't want to stand too close, right? If you're just listening, there will be a delay for the sound to get back to you, which throws it off a little bit. Okay? So let's try this. Let's say you time it and it takes 3 seconds to hit the ground. How high up are you?
48.
I want you to write it down and solve it. Or at least do it on your calculator maybe. So think about, basically this is your height, right? By the time it hits the ground, it has to be equal to each other. So if this is falling for 3 seconds, beginning at 0 speed, then you don't need the negative now. It's just 16 times 3 squared. So 16 times 9 is what, 151?
140.
Yeah, no.
That is. 3 squared is 9, and then
9 times 16?
is
Negative
144.
44.
So you're 144 feet. Oh.
That's what
So there's a corner, I don't know if you guys go to Glade Park, which I'm kind of excited about this because I saw an article yesterday that they've seen a wolf up in Glade Park, one of the released wolves, so that's cool.
There was also a murder up on Glade Park yesterday. What?
Oh, cool.
Okay, well,
What did we do?
anyway,
I don't know.
there's a corner on your way up there that it gets pretty close to the canyon and the monument, and I have always wanted to rappel off there and then hike down out of No Thoroughfare Canyon. So one day I walked over there and wanted to know how high it is, so you know what gear to bring, and I did this. I actually used this. Now I can't remember what the distance was, so I'll have to do it again, unfortunately. But you can stand there and just drop something off and estimate, probably within a safety margin, how high up you are. There is a little bit of error elsewhere, which would be what? Anybody know? Well, let's say you're looking at it, so you're not waiting for the sound to come back.
How big your object is.
Why?
Because if it's heavier, it's going to have, the gravity is going to have a stronger pull.
Which affects what?
Initial velocity.
Well, it's just a drop.
Which affects the time.
The height of you, you're not measuring the height of you.
Let's really emphasize this. What if I drop like a nice dense piece of rock that I found on the ground, which is what I did, versus like a Coke can, which I wouldn't do, but an empty Coke can, what would that do?
It'll take a
Coke
while.
can.
Oh, well, if it's empty, it'll take long.
Yeah, if it's empty, it will kind of flutter down, right? So I'm talking about air friction, right, or wind resistance can throw this off. But with a rock in the distances that I was looking at, it's not that big of an error at all. So try this next time you're out somewhere. You could even sort of, I don't know if you could do it off the top of your house. It would probably be pretty hard
Well, depending on how your house is.
because it would only fall for a split second. So you're probably going to have some error there.
And what would you put for the negative 16 squared? Or just,
I did that right here.
yeah, I know, but like, is that just the default for anything when you're
On
like,
Earth,
dropping
yeah.
off? Okay.
Because remember this, the gravitational acceleration, which is what's making this go. Like if you just drop it, you're not throwing it, then what's making it go down is only gravity, right? So every second, let me write this first. 32.2, the 0.2 doesn't matter right now. Here's how it looks in physics concept. 32.2 feet per second every second. So every second it's gaining 32.2 more feet per second. Its speed is increasing.
Okay.
Yeah, and that's true on Earth. Like if we went to the moon, it's a lot less than that.
Interesting.
It's like a third of that.
I
or
think
less.
I will use that now. That
Like
sounds
a sixth,
sounds
maybe.
cool.
Yeah, it's cool.
Let me figure out how.
Just gotta like write it on my palm next time I go
Okay,
hiking so I can
so
look
if you're
at it.
like-
I can remember this one.
Yeah, and you can just use your watch or your phone and time it out. All right, let's check that homework. Any of these that you'd like to do from last night? 27. All right.
So you would eventually hit 16 million.
Okay, the
miles
other,
if you jumped out
I don't know what
of
he's
the
talking about, but it reminded me the other limiting factor of that. Have you heard of the phrase terminal velocity?
Yeah.
Okay. Basically what that means is the force of friction, air friction, matches the force of gravity. And so it's no longer accelerating, and it's just a constant velocity. So that would not work once your object reaches terminal velocity. But that's not going to happen in shorter, like reasonable distances.
What's the terminal velocity?
It depends on the object because it depends on its. There we go. It depends on the friction that it's experiencing from wind. So think about like when someone's skydiving, that's terminal velocity for this shape of a human, right, coming down. And then if they tuck, it gets a little faster because their wind friction is less. That was weird.
What are the rules for long jumping? Kind of random.
What is going on? Oh, I know what's going on. There we go. All right, what are the rules for long jumping?
Yeah. I was thinking like what's like
Basically, you have like a start lineup, and then you just run. And
I know, and then there's a line, and if it's on the line, it doesn't count. I'm talking like when it comes to landing.
landing.
Do they measure from the first mark in the sand?
So would I be allowed to land on my hands?
Yes.
I don't know why you would. You probably
Oh,
only do that
landing
once.
and then like flip forward.
Yeah, that way you don't fall backwards.
Okay, but they would measure your hands.
That's
Yeah,
fine.
but you're
But
not
the thing is, you're
gonna
like also
fall
leaning
forward.
forward too, so it's like you get an extra 5 feet from your.
I'm pretty sure there's a.
If
I
you
mean,
fall backwards, then
if
they
you-
measure that way.
if you
Okay,
fall.
but the thing is, like, you're going so much inertia. If you land on your hands,
There's a high
Well,
chance
then
you
you like
could break.
tap
something's gonna happen,
Land
bro.
on your back and then roll you forward.
Yeah, I mean, bro, like people jump from high places doing parkour, like doing the rolly thing with your
They
hands. bro,
have a
like-
special pad on their shoulders so that when you go.
Yeah, but
Wear
this
special
is literally
pants.
just long jumping. Like this isn't all
True,
you're
but
doing
you're
is
landing-
running as
but you're
fast as you
basically
can, and then
landing-
you're jumping far.
But you're basically landing right on your arm. Plus, they don't. They
Oh,
actually just roll immediately.
I
They
think
try to
the
get
I
that
think the
movement.
difficult part would be getting height because the point is distance, not height. So being able to like land on your hands and be able to roll forward is the problem. That's why you keep it on.
they land on their bum, actually.
I mean, they try to land on their feet.
No, they don't.
They use their feet to get their front.
They land like this.
Yeah.
So they kind of hit bum and feet at the same time.
Okay.
Yeah. And it's usually their bum that gets marked.
They don't do their hands because it'll. break
Which
out.
part of this do you need to do? If it's all of it, that's fine. But, okay. All right. So graph, we know it opens down, but it's got a y. Let me just get rid of that. So our y-intercept is super low. We're not going to graph it down to actually 35,000, of course. So y-intercept down here at negative 35k. Okay, it's opening down. The graph pattern would be over 1 down 10, over 2 down 40. So it's going to probably come off your page really quick, off your setup graph, unless you scale this maybe by 50s. You might get a couple graphs out of it, or a couple points, I mean. And then our vertex, which we need anyway for this problem, opposite of 1500 over 2 times negative 10. So whenever that is, 1500 divided by 20. 75. This is all just a relative scale.
Okay.
And then plug in 75 back in here for the y coordinate. And this is going to tell us if we're above or below the x, but we should be above. Yeah, we're way above. So 21, 25. I'm using K for 1,000. Okay, so it's doing something like that. Okay. Anyway, now we've basically answered this. How many admissions counselors should they employ to maximize? That would be 75. And then what is the maximum profit? Would be the 21,250. Is that good?
Yeah.
Any others? All right, so for 23, for the 3 equations, your equation should be negative x squared plus 2x plus 8. So negative 1, 2, and 8 were your a, b, and c values. 24 should have got 2x squared plus 4x plus 2. So 2, 4, 2 for x, or for a, b, c. 2, 4, 2. And 28, vertex form, y equals negative x minus 12 squared plus 144. And your maximum area is 144 square feet for a length and width of 12. How'd that one go? So what are we looking for to maximize the area? We're looking at the vertex, right?
Yeah.
Okay. All right, well, if on the graph, the vertex is at 12, and then you can't really get the detail of 144 from the graph, but solving by plugging in 12 for both. All right, how you doing on this stuff?
Yeah, it's like a parabola, you know? Sometimes it goes down, sometimes it comes up and back down.
If as long as it's an upward concave
was-
up parabola, you're in good shape. What does that mean?
-5.
Well, I'm curious what's going on.
I'm having the same problem. Like,
Okay.
I understand all the math,
Yeah.
but like, I'm like, I don't even know. Something like, I'm like confident I'm about to fail this test, and that's like not like, I don't know. So I have to like study my notes or something.
So where are things going wrong?
It's just overall like,
I don't know.
general like, I guess it's just a lot.
It's a lot.
Yeah,
Algebra
so-
2 is a way harder class than geometry.
I understand the content, but I, like,
I
with
mean, the vertex
problems,
stuff, I
I
understand.
I don't know, like, what to use where, I suppose.
Yeah.
Like, just the context of the situation is confusing, and there's so much to take into account.
Just the context kind? The in
Like, I
context?
understand the problems and how to do it, and the content itself, but like,
Okay.
knowing what to do.
I guess I'm having trouble with like the minimum and maximum.
Okay.
Stuff.
Like what about them?
Just like the global and like the local.
Okay. Well, parabolas will only ever have either a global or a local, or global or, it will either only have a global max or a global min. With a parabola, there's no locals, right? Because it doesn't ever have like a little bump in it where it can have a valley or a hill. It's just overall biggest or overall smallest. Does that help that?
Yeah.
Okay. What did you say?
I said if I can get my hands on the review, I think I'd have no problem.
Yeah, honestly, I feel like
Because the reviews are always.
What if there's no reviews? That's a luxury that didn't exist very long ago.
I don't know.
What if there's not a review?
I'll deal with it.
Yeah.
You're cooked, huh?
I,
Alright, so we're throwing a discus. Anybody ever done that before?
I want it.
I used to for my
I've
Okay.
thrown a frisbee.
So this data wouldn't be super hard to gather if you obviously use slow motion, and you'd have to have some form behind the throw, some form of scale. Like it shows just the stadium behind him, but maybe if we had him throw it where we had heights behind him, where we could see the height of the thing as it goes, okay? Like a, I don't know, a banner or something, or maybe the discus is outfitted like you were tucking with some kind of a tool to measure its height as it goes, that kind of thing. We could do this with a basketball, right? So shoot a basketball, that would be easier. You could, on the gym wall behind, you could have the heights and watch the basketball travel in front of the heights as it goes to the hoop. Anyway, it says the coach is recording the horizontal distance, so not time this time. This is the first time we've done a height versus horizontal distance comparison. So horizontal distance is our x coordinate, height is the y coordinate. It says all of this is in meters this time, not in feet. So if we could get a function rule, what shape is it making, first of all, or roughly? It's going to be a parabola, right? Because once he releases it, it doesn't have its own propulsion, so this is projectile motion. Just like the rock that we just talked about. Anyway, if we could get a function rule for that, we could help him predict heights based on his throwing, right? Well, there's lots of points. So what did you do yesterday to find a function rule for that? Any? Yeah, you picked 3, and then you found A, B, and C. How would that feel on this?
Pretty easy. Like go one from the bottom, one middle, and then one the top.
Okay, except for look at your values. It wouldn't be super easy, because all of our y values in the equations would all be a decimal, right? So, I mean, it wouldn't be horrible, but it wouldn't be great. But if we take this data and use our calculator, it's a lot faster to do this. And once I show you, we'll go back and do your homework problems with this and see what you think. So let me show you how we're going to do that. We're going to use, so from the green button, it's 2 to the right. It says stat. Have we done this ever before? I don't think we have we? Okay. So try to stay right on top of this with me. So hit stat. And you know what? Does anybody have anything in your calculator that you just absolutely don't want to lose?
I have something stored for chemistry.
Okay. Well, then you don't do this, but everybody else, I think before we do this, let's do a memory clear. Because sometimes these rental calculators get hung up. But also then you don't have to deal with any data in there already. So seconds plus, and then 712. Just hit that series of numbers. Second plus 712. Yours. We don't need to do that. Hit clear, so you should be on the main screen again. Okay, so hit stat, and then what stat is it's called a list editor basically. If we hit enter on edit, it's going to bring up L1, which stands for list 1, list 2, etc. This is where we can enter data, and it goes up to list 6 on this calculator, I think. But we'll just stick with list 1 and 2. That's what it defaults to. List 1 will be X's and list 2 will be Y's. Okay? And we just need to enter that data in. And let me kind of show you and then I'll clear mine. So keep your eye up here. It's just like entering a number and hit enter and it drops down. So you want to do all your X's and then go over and do all your Y's. So 6, 8, 3, and then you're just filling in your X's. Okay? If you mess up, you can just clear the value in the box by doing delete, I think. Yeah. So this button up here by the across from the blue is called delete. And if you mess up the whole column, you can arrow to the top and hit clear. Don't hit delete. It will delete that whole list, including the variable. So hit clear and then it's gone. Okay? Clear at top, delete down inside. So I'll put this data up here and let's go enter it all together. Alright, so once you have your data entered, we can tell the calculator to treat this like X's and this like Y's. Go back to the button, hit stat again. There's a lot more that this can do that I'm not going to show you at this moment, but if you arrow to the right to calc, we have lots of different kinds of regression. You remember that word from Algebra 1? Okay, regression means, in this case, actually in all cases, regression means find the line or the function rule that best describes or matches the data. Okay? So think about if this data didn't kind of curve off at the end, if it just kept going like this, what would be a good model?
Straight line.
A linear model would, right?
Yeah.
A line. Okay, so that would be linear regression if we think it looks like a line. And sometimes you don't know. Okay? If it did this, like if the data came up and then it came down and then back up again, that would probably be like a cubic regression. It fits that shape better. But this one we know two things. We see it kind of curving. Honestly, the data doesn't look like it does much at this point, but we know it's going to curve and come back down, don't we? Okay? So we know a quadratic model is probably best.
So it'd be quadratic, right?
So quadratic regression, it will try to fit a quadratic model or equation to this data. And that one is number 5. So arrow down or just pick number 5. Okay, here's where you need to check and why we reset our calculator, because it defaults to list 1 and 2. So if you put your data somewhere else, you need to change that to like 3 and 4. Can you guys quit, please? So just arrow through those.
How did you get to what?
Yeah.
That was stat, arrow to the right to calc, and then just number 5, quad reg. So number 5.
It just says
Quadratic.
quadratic.
Yeah, yours. Well, which version do you have?
TI 84 plus.
Okay, so if I switch over to that one, I'm gonna have to re-enter all the data. So yours, did it put it on the home screen? Okay, so you're okay. You can choose to store this, and it will automatically dump it into your y equals, so then you could graph it if you wanted. Graph it with the points. Maybe I won't do that right at the moment. So if you have yours, if it just copied a command to the main screen, you just hit enter. If you're like this one, just hit enter on calculate. Okay? And look what it gives you. It tells you the form that it's giving you, which is standard, and then it gives you A, B, and C right away. In other words, it basically did that system of 3 equations, sort of, only it's using a bunch more. It's a different process, but it's that same idea.
Mine just.
And you could just plug these right into your standard form. And now we have a model for that function, for that toss. Okay? Pretty nice, right?
Yeah.
Okay, well,
So that is quadratic regression. Guys, this stuff is extremely useful. One of the projects I had to work on in engineering school is we were doing a water quality analysis in Fort Collins. Colorado. We started at the headwater, clear up the river, and then we took samples there and at the water treatment plant, and then through town all the way to like some of the farthest reaches of the water distribution. And we modeled it for a bunch of different water quality parameters using this kind of stuff with regression. And we didn't know what the data looked like because it was, we don't expect it to be necessarily a parabola, so we had to try lots of different regression models. Like if you don't need to go here, but you can see all the different ones, like linear, quadratic, cubic, quartic, natural log. That was one that, I don't remember what ours turned out to be. Exponential, power. It might have been a power series that we got actually. And there's ways to know which model fits best. So this is cool stuff that we're learning, right? Any questions on how to do it? So I want you to go grab your homework and do this for the 2 different problems that we did, the 3 systems of 3 equations. So it was 23 and 24. And see if it matches what you got for your model. So just one whole regression for those 3 points, and then one for those 3 points, okay? Just to practice. That means you'll have to clear out the data that we just put in. Remember to use clear at the top.
Well, my calculator doesn't like to do it. It just shows me an error.
Then you're doing it wrong.
I did it exactly right, so.
Nope, you're probably doing that.
Nope, I probably did it right, because I checked like 3 different
What
times.
nice looking parabola. I wouldn't mind that.
Well, it's always still around, we just have to.
Yeah.
All logarithms getting first?
STD would turn into mosquito illness. I was at COVID. I was, well, again, no, like, you see that reaction time?
Oh, main key tank.
Yeah, immediately get STD, and now it's like,
Okay, so if you're given multiple points, use your calculator to get a quadratic model. Guys, model means equation. When you're doing applied math, you don't really call it an equation as much as a model. So you're going to hit stat, and then edit, enter data, x is L1, y is L2. Okay, and then you're going to hit stat, arrow to the right, and do calc, and then quad reg. Alright, that'll get you far enough, I think.